Okay, this is a circuit diagram of a KB BM20 radio, Coulter brands, using this, a mains transformer, instead of the dropper resistor we looked at in the other circuit diagram video. This is the mains in, there's the on-off switch. Best to have this one live, so you've got live through the switch. This is the primary of the transformer, and these are mains taps, so you might have 250 volts, say 230 and 210, something like that. Okay, mains in through the switch. In this case, a single switch, single pole, not a double pole switch. Right, the other side of the transformer, we have these valves here have 6-volt heaters, all right, and they're in parallel. And here is the 6.3 volts. These are the 6.3 volt connections which go to each valve in parallel. Also this valve here. Okay, you can see that the heater is actually wired across there. So instead of the valves in series, they're in parallel. This is the rectifier audio output. So what happens is this is the heater connection. We're not using a mains dropper at all. So you can earth this chassis. In fact, there, if you can just see that, that's the little earth sign. So you can actually earth the chassis. It doesn't matter which way round the mains goes in, the chassis is completely isolated. Having said that, still use your mains isolating transformer when working on any radio. This is a full wave rectifier. Okay, this is the HT winding, the secondary HT winding, the centre tap of which goes to the chassis. Okay, then you've got one to that anode, one to that anode. I'm not going to go into full wave and half wave rectifiers at the moment. This is purely how to read circuit diagrams. HT, okay, so AC goes in here and here. HT comes out of here, the cathode. Alright, this is HT. Say, I don't know, positive volts with respect to the chassis. Say 250 volts positive. Alright, the negative connection is the centre tap in this case, there. So the chassis is always negative. As opposed to the HT, which is up here, is positive. Here is a little bit of a funny way of drawing this. Here are the electrolytic smoothing capacitors. This is the HT out, remember, our 250 volts positive. 16 microfarad smoothing, electrolytic, again, round the wire the right way. Here, smoothing resistor, part of the smoothing and filtering circuit. Here is the other capacitor, 24 microfarads. So these are the two electrolytic HT smoothing capacitors along with the resistor. That is the smoothing network. And basically that's it. So as I say, you can earth this chassis because it's using a mains transformer. Now I'm going to show you another circuit in a while which uses a mains transformer but has a live chassis. Now there we are. So don't give yourself a hard and fast rule that, oh look, there's a mains transformer, the chassis won't be live, because in some cases it will be. Okay, that's the mains transformer dealt with. Just briefly, up this end, this is the aerial. Alright, this is the aerial coils here. There are two coils. This is like a transformer here again. There we are. This is the tuning capacitor, the variable tuning capacitor. What they've done across each one is a preset. Now in this case the preset is denoted not by the little bar across but by dotted lines. Okay, so these are the two here turned by the control knob for tuning. That's the aerial part, the oscillator part, and these are padder capacitors or trimmers, preset ones which you adjust with a screwdriver. Medium wave, long wave switching is there. There should be another one somewhere there. Okay, basically on long wave that switches in the long wave oscillator coil, medium wave oscillator coil there, and here aerial switching long and medium wave. But the important thing here is this mains transformer. That's what I wanted to talk about. That, as I said, is a full wave rectifier. I'm going to do a video on power supplies at some stage because they can get a little bit involved and I think they deserve a video of their own. Bless them. Okay, next we're going to move on to the video the circuit diagram with the mains transformer and a live chassis. Right, another circuit diagram. Here we have a mains transformer. Now, as I just said, looking at the other circuit, don't think that because there's a mains transformer the chassis is isolated from the mains. Look what happens here. This is the mains in, the AC mains coming in, double pole switch, one here to the tap, say 250 volts, 230 volts, something like that. Look where the other mains connection goes, through the switch directly to the chassis. Now, why is this? Why have they done that? The reason is, well, it's basically cost. This is a little bit more expensive than a mains dropper, but not quite so expensive as a full mains transformer. What they've done is they've used this winding here as more of an auto transformer. That's another type that I'll show you after this one. Now, basically, the mains comes in here, there, and back to the neutral. That is the primary, but it's onto the chassis there. This X here, this is the valve heaters, you see. Now these heaters are all in parallel, alright, so they're not in series, they're in parallel, and this here will be probably, I don't know what these valves are, probably 6.3 volts, okay, between the chassis and there, that tap there is 6.3 volts. Now the HT is taken directly from the mains here, okay, through that resistor to these two anodes, alright, so it comes straight in here. This is the AC to the rectifier. Then the DC comes out of here, alright, to the positive of that first smoothing capacitor there. Okay, so this is a very odd way of doing it. This winding here is probably a 5 volt. Again, I don't know what this valve is. This is a 5 volt heater winding, or 4 volt, something like that, something rather weird. That's why they've had to do that. So there's the heater with its 5 volt winding. AC goes in the two anodes here. This is the cathode, which goes to the positive of that electrolytic, and then we've got up here, that's the supply to the output transformer there, which feeds the anode of that, and then it's taken up here. This is now the HT rail. This is a rather complicated way of doing it. In fact, what they've done, they've used this output, part of this output transformer here, as the smoothing part of the smoothing circuit. So this is the DC. There's one capacitor there. This is the DC through part of the output transformer there. That's the second smoothing capacitor, and then this is the HT rail. Hopefully you won't come across this sort of arrangement very often. So remember, live chassis. There's the supply to the anode here of the audio output valve. There's the speaker. This is the output transformer. The supply, the HT supply to that anode is here, there on A. See where it says A? Or is that B? I can't quite work out what they're trying to do there. But that's there, and then down to the anode. And then the HT for the rest of the radio is taken from the top of that coil along here. Rather odd way of doing it, but as I say again, I know it's boring, but as I say again, don't just look and think, oh look, there's a mains transformer, that's simple, the chassis won't be live, because it is. And as you can see, if you wire this around the wrong way, this is live directly to the chassis. Okay, that's that one. And there's a third one, an auto transformer, I want to show you. I couldn't find a service manual circuit diagram with an auto transformer, so I've drawn one. Mains in here, neutral, live. Neutral here because this is the chassis, okay, double pole switch in this case. So here, through the auto transformer, and there. Right, that part of it is exactly the same as an ordinary mains transformer if this would be the primary. Now what happens is here, the live comes in here, the other end of the transformer is the chassis, that's neutral, okay, so we want to again wire this round the right way, otherwise we'll have a live chassis. Now instead of a second winding, a secondary winding, there's only the one, and what they do is from the chassis to here they tap off the heaters, whatever heater voltage you want, and from there to here tap off the HT voltage. This is AC, which goes to the rectifier. This goes to the valve heaters. Now in this case, with this sort of arrangement, normally these heaters are in series. Okay, so they just tap off whatever voltages they want here, and that is an auto transformer, in other words one winding. Alright, so again, don't look at the chassis and think, oh look, there's a transformer, I can earth the chassis, it's not live, because if this is wired round the wrong way, then it will be live. So that's briefly an auto transformer. Right, that's it. Hope you enjoyed the video, hope you learned something. I will just say one thing before finishing this video. Mains droppers were originally introduced not only to cut costs, because they're a lot cheaper to produce than a transformer, but in the UK some areas had DC mains and some had AC mains. In fact, originally I believe it was all DC. Now a transformer of any type will not operate on DC mains. It'll either blow the fuse or cook the transformer. So they needed to produce a radio that would work on both AC and DC without changing anything over on the radio. Plug it in where you like in the country and it'll work. So they used the mains dropper. Then later on, as more and more of the country became AC, as it is now, all AC, they used transformers. Having said that, in the 1960s and 70s they were still producing televisions with mains droppers. That was purely to cut costs though. So that's it. Look out for hopefully many more videos. Thanks for watching.